we almost have everything we need to know to do a full and proper hypothesis test. There's just one topic we still need to cover before we put it all together. When we calculate a p-value for a hypothesis test, we start by assuming the null hypothesis is true, right? That p-value is meant to help us know whether there is enough evidence from our sample data to reject the null hypothesis and accept the alternative hypothesis. Because that p-value is helping us know if there's enough evidence to determine if the alternative hypothesis is true, that alternative hypothesis actually has a big role to play in how we calculate that p-value. Okay? And it helps us understand where we should calculate the probability, whether we should find the probability in the left tail and do a left-tailed test, whether we should calculate the probability in the right tail, do a right-tailed test, or whether we're interested in either tail, whether we should do a two-tailed test. Okay? The inequality symbol on your alternative hypothesis actually indicates which of these tests you should do. Okay? So let me make a little table here. So there's our test. And our alternative hypothesis symbol is what determines which test we perform. If we want to do a left-tailed test, we do that when our alternative hypothesis uses a less than symbol. And the reason for that, if I just sketch a very rough graph here, is if the alternative hypothesis is using a less than symbol, we are looking for enough evidence to say, no, the null hypothesis is not true. In fact, we believe that the population parameter is actually smaller than what the null hypothesis said. Okay? So smaller values are to the left. And so that's where we look, in the left tail. If the alternative hypothesis has a greater than symbol, then we do a right-tailed test. Because we want to see if there's enough evidence to say, the population parameter isn't what the null hypothesis says it is, and in fact it's greater than that value. Larger values are to the right, and so we would look for the probability in the right tail. And sometimes we just want to know if the population parameter is just different than what the null hypothesis claims it is. Okay? If it's just not equal to, then we do a two-tailed test, because all we're interested in is the population parameter different than what the null hypothesis claims. And so it could be smaller or it could be bigger. And so we look in both tails to see if that population parameter could be far enough away from what the null hypothesis claims to be able to conclude that the alternative hypothesis is true. Okay? So how we test our hypothesis depends a lot, and how we calculate the p-value depends a lot on that alternative hypothesis symbol. It determines whether we do a left-tail test and we calculate the probability in the left tail. If we do a right-tail test and we calculate the probability in the right tail to be our p-value, or we do a two-tail test and we calculate a symmetric probability in both tails, and that's our p-value.